Morning, and thank you for joining today's webinar from Spec Innovations, bringing clarity to complex systems with Innoslate. My name is Taylor Duffy, and I will be the moderator for today's webinar. First, I would like to go over some housekeeping. During the presentation, feel free to send us questions, and we will get them answered in the Q&A part of the webinar. You can also interact with us on LinkedIn through the Innoslate users group or through X using the handle @SpecInnovations. The webinar is being recorded and will be made available to you after the live presentation, so keep an eye out for it in your inbox. Now, I would like to introduce you to our presenter, Spec Innovations President and Founder, Dr. Stephen Dan. Dr. Dan has been involved with research, experiments, operations analysis, software development, systems engineering, and training for more than 40 years. He also received an Expert Systems Engineering Professional ESCP certification from INCOSE. He is currently applying systems engineering techniques to various DoD, DOE, and commercial projects. Feel free to send him any questions through the LinkedIn users group or send him an email to steven.dan@specinnovations.com. And now I'll hand over the controls to Dr. Dan and we'll get started.
Thanks, Taylor. So today's agenda is pretty simple. We'll just do a few slides and then we'll jump into the demo, just kind of give you an overview of some of the key things about complexity. So we're going to talk a little bit about visualizing and analyzing system models in real time and how we can do that. I'll talk about the enhanced traceability that we've used, particularly where we've used AI to help us give us insights into that traceability. Also streamline collaboration and decision-making and improve requirements management and validation. So there are many other aspects to complex systems. So hopefully you have many questions and we'll be able to answer those for you. So to visualize and analyze system models in real time. Now, Innoslate really gives you a variety of ways to see the information, and particularly in terms of systems modeling. There are, of course, many languages out there: SysML, UML, LML, IDEF, and many even before that, like N-square charts and things like that. So there are many different ways to visualize the information and be able to articulate it and use it for doing this kind of analysis. We also have tools that are available for most diagram types. So you can do things like we have checkers for like the behavior model, so you can use the simulators for that purpose and check and understand what's going on with it. The physical I/O diagrams can identify problems, missing information, and errors from the I/Os and conduit paths. So again, these are some of the indicators that are in there. I'll show you these in the demo. Another whole view that's really pretty significant for us for that, showing that capability, is intelligence view. This is a set of 68 heuristics that were developed by Naval Postgraduate School research, Dr. Kristen Giamarco's work, if you're familiar with her work. And it's really quite helpful in looking at potential issues and things about complex system models. Traceability, again, we have something we've had for quite some time, actually, where we use natural language processing algorithms to do the traceability assistance. Traceability is something we, of course, provide automatically bidirectionally. It's part of the lifecycle modeling language, which gives us our underlying schema that we use for our database. Those are important. So the traceability assist uses those to look at the information associated that you're trying to connect things with and help you determine whether or not they should be connected or should not be connected. We also have been adding a new thing with the generative AI, where we can create risks and test cases from the requirements and automatically create traceability between them. That's a very powerful way for you to make sure that the information is connected correctly. Again, wherever we can, we are behind the scenes creating these relationships for you. so you don't have to worry about it. It's because it's hard to keep all this in your head. The relationships are really the complexity of the elemental language. Streamline collaboration and decision making. So again, Innoslate was designed for collaboration. That's actually one of the major reasons we started on the cloud. Being a cloud native tool enables you to simultaneously work on the same database at the same time as a lot other people. And the Innoslate projects themselves can be shared with whoever the owner wants to share them with. So that's important to recognize, because now you're, as the owner of that project or the creator of the project, you're the one who is in control of how you collaborate and who you collaborate with. So we have some tools in there to help you with that. One of is the group and private chat. That's built in, so you could have that. So if you don't have a chat app that you're used to using with your team, it's built into Innoslate so you could have that. In fact, I think we put that in there originally early in the process before a lot of those kind of apps were prevalent. So it's something we've kept because it's very useful from that perspective. Decisions themselves. Now, there's actually a decision class in LML, if you're not familiar with it. In fact, John Fitch from PPI has done quite a bit of analysis and use of extending that. We're hoping to look into how we might be able to apply more of that into our decision process. But basically, you can capture the decisions, you trace them to almost any other thing that the source of that decision. And this is a good way for you to make sure that you don't miss these important decisions along the way. Who made them, why they made them, those kind of things often get lost in a project. And later on downstream, everybody's wondering, well, why did we do this? And all that history and thought process gets lost. And so highly recommend people be doing that, particularly associated with your milestone reviews and things like that. If nothing else, make sure you capture those decisions explicitly. Other things to look at, of course, we provide cost, schedule, performance, and risk, and other metrics that you can identify and use, and then they can be provided to the decision makers on the dashboard. So again, the results of things like status. People are always wondering, well, what's the status of my requirements? What's the status of my test cases? You can that's another good metric you can put up there. Again, having that in a simple, concise form simplifies that for the decision makers, even though you have a very complex system underlying it. So you have the ability to summarize and bring that information up to a higher level. Improve requirements management and validation. So we've certainly done that. Again, one of the things that people keep saying, model, but requirements really can't be just modeled. We have often tens of thousands of requirements for a complex system. And so you're not going to put that in a diagram. Sorry, just not going to work. You can imagine that diagram would be very, very small, have very small points in it. And so to realistically deal with it, we've created a requirements document view. So again, the requirements are still database objects, but they're visualized as a document type. Again, you can create diagrams and things from those requirements just as well, hierarchies and requirements diagrams from SysML, things like that can all be developed, but really to deal with the kind of number of requirements we have in a real system, you have to have it in a document-like form. Now, we also, to help you manage that, we of course allow baselining. So baselining is a key capability for requirements documents. And then we also have workflows. So you can set up the workflow management as you need to throughout your process. And that can be set up with individuals or groups. There are different ways to do that. Requirements validation. occurs through our quality checker primarily. That's the #1 source. We upgraded that now. I want to say maybe over a year ago now to the latest INCOSE requirements for quality. So we make sure we had those up to date. And of course, we have some of our own checks as well, in addition to the INCOSE ones that we've had. Intelligence View also provides some of that capability. Particularly, there is a specific ones for requirements in Intelligence View, which I'll show you. Another place where you can do validation of requirements is using functional modeling and simulation. You take your functional requirements and put them into an action diagram or activity diagram from SysML, and then use the discrete event Monte Carlo simulators to verify that they work. And so, at least if nothing else, that's done. But the nice thing too is, from that work, if you start putting in the right timing information, resource utilization, input outputs, and acting as triggers properly, all those kinds of things that you can do particularly in the action diagram, allow you to derive potential metrics like timing, how long something's going to take. And so you can look at those kind of metrics and see if it's going to do the things you need to do. Another is, of course, creation of test cases. One of the things I've always wondered about is we say that a requirement has to be verifiable or be able to validate the requirement, right? Again, I'm kind of using the same term for that. But basically, the idea is, if I could create a test case for it, I know I can actually test it, and again, when we say the word test case, we don't mean just test. It means, so it could be by analysis, it could be by simulation, it could be by inspection, it could be by warranty, it could be by any of the things that are other mechanisms. So we just call them test cases as a general term. But basically, being able to create those from the requirements automatically now, what we can do with the generative AI, makes it so you can be sure that now these requirements are verifiable. And that's important to be able to do. So that's something we're really trying to bring that test and evaluation earlier in the life cycle, at least in terms of being able to create those test cases, and particularly, wherever possible, use the simulation to kind of determine whether or not it's going to meet the kind of goals that you have overall for the project. Another area of really helping us with management of requirements is the branching and forking. So branching and forking, if you're not familiar with it, is very similar to what's done in tools like GitHub or GitLab or Jira, where they can take portions of the project or take a copy of the project, make changes, and then push the changes into the main part of it. So that's the branching part. The forking would be, you're making a copy, and your intent is that you're not going to merge it back to the trunk. So again, those are really great configuration management tools for your project. Okay, so again, I could say all these things, and I probably could give you about 20 or 30 more slides, but it's a lot more fun to jump into the tool and kind of go through some of these things that we just talked about and see them in action. So let me do that. So let me jump over here, and I'm going to use my Fireside example because it's my favorite. It's the one I have most stuff in it and ready to go. Here's the dashboard. So this is a good example of showing some of the status of things. So here's my V&V status. So it's a bar chart showing my test cases and what's their state. And this is just obviously very simple. If you have a complex system, these numbers would be much bigger, right? You'd have many more that you'd be looking at across your set of test cases. Those are all adjustable here in the widget. So again, it picks what you're looking for. It's an enumeration. It picks the status. It's picking the status from the V&V cases. So I'm going down and I scroll down to test case for status, and that's the one I've picked. So it's obviously yeah, here it is. So I just select that one. So that's why I know it's the test cases. And you hit set, and that gives you your test case set. So obviously I could do that with other things, other statuses, like requirements or things like that. What's their status? Another example is you can create tables. This is the table of the most recent top 10. That means that they've been modified. Notice these tables can be scaled up to larger numbers. However, in general, you want to keep it fairly small. You don't want to have a lot there that's critical. And you can set up other ways to look at the information. So here's a place where you can set these status bars. Now, of course, another thing you can do, since you can add a widget to anything, okay, you can go through and have other places you have diagrams and other information sets here. So that's another thing you can do. So lots of things there. So that was one of the areas particularly I wanted to show. And then in here, for you to help you communicate work that you've been doing, we added presentation view. So this allows you to take and have different models you're working with, and they can be expanded. Here, I can just go right to that model, and then I can just come back to it from it. And so, so you can see how I'm putting these models here, and I can explain them to people. So this is how you start building your briefing charts and things like that. I know a lot of you going, well, I got to have to send it to PowerPoint. Well, that's okay. If you go to the actual presentations view here, so let me go to presentations here. That presentation can be downloaded as a PowerPoint. Okay, so you have a very nice conversion into PowerPoint. It's all there for you. So the purpose of this primarily is for you to be able to annotate your information in a form, and of course now make it available for people to see right on the dashboard. So as a presentation widget. Oh, by the way, here's another bar chart with requirement status. Some other things here, change requests. So these are showing where someone's made a change request. And as the owner, I would go through and decide whether I wanted to accept it or not. Also, you can help track things with Kanban boards. So those are here. So you can track that. And we do have it sortable. I believe now we can sort this by person and things like that. So there's a lot more things you can do. Sort tasks by name, number, signee. So that was something I think if you've not seen Innoslate recently, that's something we added not too long ago as a feature. So again, a lot of people like Kanban boards because they help you organize and deal with the complexity of the problem by putting it into these different states, and that makes sense and helpful for people for that. So yeah, the dashboard is your window into things that are going on. I mentioned modeling simulation. If I go to the action diagram here, we saw a little bit earlier. The simulators are here. It's discrete event and Monte Carlo. If you're not familiar, what they do is they look at time, particularly. So we have the ability to put time. This is duration of an action, and it is in certain. This has to be a triangular distribution. That's a very common thing you do early in the life cycle. You may not know exactly the time, or you may not have a lot of information, but you can kind of do your best engineering judgment for how long a task takes or a step takes, and so. This lets you do kind of best case, worst case, and what's most likely to be. And you can put those numbers in and at least start there and then see how feasible things are, particularly by running the Monte Carlo. because the Monte Carlo will then take the random seeds. A discrete event will take a random seed and run it for one pass, and each of these have it. Then the Monte Carlo accumulates those over time and gives you the more in-depth information. If you're using SysML, that's not a problem. We fully support SysML. Here's an activity diagram, and it still has that discrete event Monte Carlo simulator built into it. So again, you can execute your behavioral models in Innoslate just differently than what other tools do. Other tools do it through, frankly, I thought it was kind of kludgy what I saw going on through the parametric diagram or something like that. I never quite understood state diagrams, execution. You can model states as in the behavioral model. In fact, very often that's exactly what you're doing. If you look here, you've got two states. One is normal, the other is contingency. So that's actually showing states. So again, I actually tried to use the state diagram and a few other diagram types back in the 80s, or late 80s, early 90s. And once I found this behavioral modeling approach using the what we call now the action diagram or the activity diagram, and coupling it with the simulation, you've now taken what was hard to do and more complex and actually simplified that whole process. So this model gives you all your behavioral analysis you need. Okay, so states from the actual executions of things like the discrete event, I can create times. So timing information. So that shows me my sequencing, timing and sequencing information. If I hit play, see it's building this Gantt chart as I go. So I guess I'll need to speed this up and it's capturing that. But you can see all the different things it's calculating and finding here. This was showing a forest fire, which is in red, and it builds up until you start putting water on it. That's the blue here in this diagram. And then so that you see it decaying, but then there's a delay because they have to refill the water tanks, and at least in this model. And so that allows the fire to build back up, and you see it going down again. Then finally it puts it out. This can go through several iterations, depending on particularly the model. But you notice here, your time information and the sequencing is all shown here of your actions. So here's my action entities. And of course, I can output this if you want to Microsoft Project, so you can actually see it in a project file if that's how you like to see these things. So we do have exports to all the Microsoft Office products, and we can import from all the Microsoft Office products too as well, really. I think the only one we can't import from right now is PowerPoint, but that's certainly on my list. But anyway, you can see how you can get a lot of information with this. You can make calculations. You can write things to the console. So as you're going through different steps, you can see here how often I had to refill the tank. So that showed that there's quite a number of refills going on here. So let's see here. And of course, it does accumulate cost for you as well. I've seen people struggling with that using other tools. We built it in directly. We thought cost analysis was kind of fundamental to systems engineering, so it's here. Again, taking this complex process, I can go and run the Monte Carlo simulation to get the big picture. And so if I run the Monte Carlo here, oh, I've got it set to 1,000, sorry. This will take a few seconds. Actually, let me stop it and restart it there, because that's, we don't want to take that long. Carlo, I mean, it's relatively fast, but it's for demo purposes, it's sufficient to do the 100. These simulators, by the way, run in the browser, so they're using the browser memory. So there are things like in the discrete event chart, we have a few charts like the Gantt chart and the 3D picture of the model that could get too big, and so we give you those as options whether to show those or not because of that. Here's a good example of the breadth of the time. So this is anything from roughly 12 days to 2.5 months to 2.25 months. So just that's the variation in time of this. And similarly with cost, this is 300,000, less than 300,000, going up to 1.2 million. So again, you can see how your system variances can be looked at and understood for that complex system in a way that now I can get my hands around. Here's my risk. So here's what do I do? Do I budget for this situation out here with a rainy day fund maybe, and recognize I'm going to be operating here most of the time. Again, these are the types of analyses you can do with the tool for complex systems. Again, this is this system, particularly if you're not familiar with FireSat, it's launching the payload to orbit and then running operations, and the operations can get pretty detailed. We've kept this still pretty high level, but you can detail each of these steps in much more depth. We decided to focus more on the response, the firefighting response. So that's where we did that aspect of it. And so that's where we got to these things. Again, for complexity, how do we simplify complexity? Well, to make this OR decision, I need to know, is the water low? So the water is a resource. So I'm tracking the water resource. And now I have to know when it's low. Okay, so it's got to detect that. So there's a script, and we have built-in scripts for OR probabilities or resources by resource. And so by picking the water resource, we use that, and then said once it gets below a certain level, and of course we have all the math symbols you need here. Okay, so you pick the right math, and then you figure out what that threshold is you're looking at, and then it'll go down the S branch once it gets below that level, once that threshold. So once the water level gets low is what this is saying. Now what did we do? We took actually fairly complex set of things and created a script for you. So this is the underlying JavaScript script. And you notice I put some print statements in here. Those are the ones we saw in the console. So that's again a way to take something that's kind of complex. It would be hard to sit down and do, and many of you aren't coders, so writing the script wouldn't be the first thing you'd want to do. We simplify all that by making it so you just see it this way through this user interface. So, but again, if you are somebody who likes to do scripting and get into it, you can, and that's why I said I put in these print statements to let me know things. So even if I don't know the JavaScript too well, I'm certainly not an expert in JavaScript. Here's a couple prints that make it simple enough to use for that purpose. So again, syntax-wise, I actually wonder if I've got the syntax completely right here. So I got to make sure I don't mess that up. So, oh yeah, you have to edit the script to confirm the edit. So if you're going to make changes, you have to come in and do it here. Okay. So I don't want to mess that up because I easily could. So again, if you're not really that good at scripting, or it's not quite your thing, that's fine. Hopefully most of the time you'll be able to just use that thing. If you do need help with scripting, we do have a guide for the scripting, so that can help you through that process. So again, hopefully most engineers take some level of computer programming, so hopefully it's not a complete surprise to you. But yeah, but if scripting's not your thing, that's not a problem. We don't force you to do that. So again, these are lots of things to look at the complexity and how do we deal with the complexity. And a lot of that too is abstraction. This ability to see the different diagrams, type C, the parent here. So abstracting that complexity. We do have the ability, if you've created a fairly complex diagram, and I know a lot of people do this all the time with the action diagram, you can select a portion of it, and if it says decompose, it'll take that set of actions you have and create put them into a child. And so automatically, so that way now you can do a better job of abstraction and help yourself be able to understand more the bigger picture of the diagrams. So that's why when you go up to the top here, I can understand what the overall operations and activities are going on here, or the launch, right? Launching a payload to orbit is not a trivial process, right? So again, having that abstraction level helps me so much in having a more understandable overall picture of what's going on. Similarly with disposal, I don't have it decomposed, but disposal is not a trivial process either. So again, it lets you kind of work with those bigger picture things and then dig down into them as you need to. You can go very deep with this. I've personally been down about 12 levels of decomposition. So you could take a very, very complex system and get it down to the places where now I can make the decisions we need to make to buy or build. Some of the other features I mentioned, so documents, of course, view has requirements document, so there's a type, and here's that quality score. So you can see how those are accumulated. That's simply the set of attributes that we have over here to the left, where we're using complete, conforming, correct, feasible, necessary, singular, unambiguous, verifiable, and I want to say appropriate. I'm not sure appropriate's there. I think actually that's probably one I added. So you can add your own as well if you decide there are ones that aren't in the list that are the proper set. When it finds an issue, it will help you identify what may be the problem. You have also, if you see an R number, that's the rule number from NCOSI that's being violated. So again, we're trying to track back to that. There are two that we do not resolve for you automatically, even if it does meet all the NCOSI criteria, and that's correct and feasible. We think those do require human judgment because correct means is it basically legal? Okay, so depending on where you are, it may be illegal or maybe not, depending on what you're doing. Feasible, again, is something that's determined within cost and schedule constraints, right? I mean, almost anything's feasible except maybe exceeding the speed of light. And even that people have theories on that maybe there are ways to do that, but it's so feasibility is a judgment. The question is, even if I can exceed the speed of light, right now the theory has it that we would have to basically use the entire power of the universe to do it. So it's not really very good, right? It's not what we call feasible. So again, these are things to help you identify the issues and problems with it. And notice this also has status, so you can do the status. Now this does have this does have workflow set up so that I go from in review to approved or rejected. So that's all I can do from in review. If I have a draft, I can go only to in review or rejected again. So again, this is where the workflow has been set up to do that. The way you set up that workflow is in the scheme editor. And there's a workflow section. And any enumerated attribute that can be set up as workflow. Normally it's status. And here I added status to the artifact itself. So you could actually do it at the artifact level rather than at the requirements level. But that's up to you and how you want to get set it up. Here you can set up different, again, permissions of who can make changes and then who gets notified when changes are made. And those can be teams or groups. You can define teams at the organizational level. Excuse me, sorry. I think allergies are getting to me this year. Okay, so lots of more things with documents. The baselining I mentioned, that's here in the More tab. That's where you do baselining. Also, we have some new AI features like summarize and translate. So if you need to make a copy of this in a different language, you can do that with translate. Translate's really a lot of fun. I think we have quite a number of different languages, Japanese, Korean, so even some of the more difficult languages. Hindi. I believe that there are language packs that can be added to this as well. So there's more you can do with that. Also within here, we have AI tools for you. There's a text tool that lets you now do your own prompt engineering and decide what you want to do with that. Or you can simply use our generate risks or generate test cases. Now, you can do that from here if you want to, but then you have to manually add them to a risk matrix or a test suite. So it's better, easier to actually go to like Test Center, set up your test suite you want. So here are some operational tests. Now, what I'm doing is I'm going now and look at my mission requirements, and I'm going to create test cases there. So I do that by going here and selecting generate test case. And then I'm going to search for mission requirements. And so maybe I have one on, let's see what Design Life has in it. So yeah, this says it has to be operational on orbit for 5 years. The system should have operational on orbit for 7 years. Now, that's interesting. That looks like there's 2 there. Now, again, this is editable as you come in here. So if you say, this is kind of confusing, somebody added this, so I don't want that. And of course, that doesn't change the requirement. You'd have to go back and change the requirement itself in this situation. But you do that. Let's just do this and see what we get. So again, it gives me the steps that I need to go through, expected results, and verification method. So again, this is all editable here. So if you decide that you want to do something different, or it's a good, you say, oh, it's a good enough starting point, and then you want to edit it in line, you can do that too. But this lets you add those as you need to. So just create that and adds that. Now what this did is it also gives me that relationship back, and we have active relationships so you can see back. So it verifies that design life. So now if I want to go back and clean up that same thing in that I said to here, this was somehow added, and this should be operational, so we can make those changes and persist them. So again, you see how quickly you can go back and forth between the different views with using the hyperlinks that we create for you automatically with the relationships to go back and forth. Again, taking these complex things and making it one thing at a time and being able to follow that train of thought. So many other things. Also now, don't forget database view. I mean, database view is actually a wonderful view. We have the ability to set all kinds of queries up. There's a very nice query editor for you, a search editor for you, so you can do things like look for specific things. Like if I want to find all the orphans, I could do that. I can pick particular classes of information, and you notice how it'll build for me that information. So there's a query here that already been started. So that's something we may want to do differently with it. But so anyway, we'll clear that right now. I'll just not do this one. This actually is a one that was set up as a saved query, and it's called the OV3. So that's where this one came from. If I want to go, once I save the queries, I can save it either for myself or to the project. So like the way you do that is you give it a name, and then you hit save, and you have that choice of saving it to the project if you're the owner or not, or you save it as a personal one. So then you have this set of queries you can look at anytime you need to look at things like my risk register. And so things like that. So again, this can be very complex. Right now I have the risks and the mitigations. I could add the cost of the mitigations as well here, information. So there's a lot of, you can build very complex tables in database view now. So if you need that level of complexity, you can do that fairly easily. Let's see, what else can I show you quickly here? Oh, so I mentioned intelligence view several times, so let's go take a look at that for those who aren't familiar. So this is the set of heuristics I mentioned. Each one of them, if you go to this is the global analysis. So I click on the settings there. I can read these and determine whether it's an error or warning or I want to ignore it. So you can add, you can basically have as many or as few as you need with that kind of thing. So this gives you that set of things. And then here's a good example of entities with similar names. That usually means that I probably have duplication going on, which isn't uncommon, particularly if you have multiple people working on something. They might accidentally create a duplicate of something. So you look at this like this final orbit radius. And then you could decide that these two really are the same thing. So I'm going to merge them. I do that by hitting the fix button and hit merge. So you can see how that would help you put that together. As I mentioned, requirements have their own special ones here as well. It's a little hard to see for me, but you know, leaf level missing the keyword shall has been a typical one. We probably need to change that to will now, since that's the operative term for requirements. So that's something they want to change in the future. But again, you can do other things as you need to. By the way, if you have good ideas for additional metrics, like I say, the 68 have quite a bit of work went into these. They're actually set theory notation information that was used to derive these heuristics. So these aren't just abstract, somebody came up with wild ideas. This is actual significant analysis that created these particular ones. Okay, so if I go back to my slides, let me make sure I didn't miss something here. So I talked about that. Oh, I didn't really show you the physical I/O diagram. So that would be a good one to show. Let's go back to the main dashboard. So here's an example first. I'll go to this one. So this is an example of showing you where there's some problems. So a typical problem you worry about is, are your units correct? So in this case, we've got a mismatch of units. So this is in megabytes, and the conduit is passing this down is kilobytes per second. Now, that's not a big deal. I mean, maybe you don't care, but if you're using this as part of the simulation, where now this has a value, not zero, but as an actual value, then having the units be the same is important, because we use that in the calculation to put in delays. So how long does it take for that I/O? So if this is like 1,000 kilobytes, right, which is a megabyte, then I would want to put that in there that way. And then when I run the analysis using the discrete event or Monte Carlo simulator, this physical constraint would be there to show that delay of the transmission of the information between these different parts. So in different subsystems. Similarly, let me discard changes on that. The physical I/O diagram. And let's go to the physical I/O. Yeah, so physical I/O diagrams have lots of different things, the indicators. So this is an example. The gold is indicating that there is some missing information. So when you see things like that, or the dashed line is saying, I have a conduit, but I don't have an I/O associated with it. Things like that. So that there'll be red showing you errors in direction, things like that. So lots of different possible problems. When you see a problem here on this diagram, we give you a repair button, and you can come in and make the change. So in this case, there was no conduit entity selected. So we want to create that and do that as part of the repair process. So again, on and on. There's just lots of different things in these tools that'll help you find. You of course check the model, hide warnings. We do an auto check for you. So if you make changes, then you get check model when you're in it. So again, lots of different features for that. Another one we talked about is traceability. So let me go to show you a quick example of traceability. So in here, I have let's see, did I? Oh, I'm in the wrong place. Let's go to test center. There we go. That's what I wanted. Test suites. And so here I have my tests associated with it. Oh, I'm sorry. I'm picking the wrong one. That's what I'm doing. I picked something I didn't recognize what I was picking. There we go. Okay, so here's a test suite for the system acceptance test, and this I have a traceability matrix set up for. That's why I wanted to get to it. So I'm going to open the traceability matrix, and I can see what's associated with it. Let's just do related and use verifies. So here's the ones I've set up already with verifications. And now to get that, those assistants, they're here in the right. So there's the traceability assist and the suspect assist. Again, these are natural language processing algorithms. It looks at the name, number, and description, which now you can see on the sidebar. And so it determines whether there's enough information that those two things should be connected. If you get a red, it may very well be that just something isn't reading correctly, or not getting the right information there. So again, we have to look at that and see what the issues are. Or maybe in the case like this, where there's no description, so there's nothing to connect the two. So again, this can be helpful for you in a variety of ways. Okay, I want to leave some time for questions because there's just so much. I could go on and on with the tool probably for another hour. So do we have questions, Taylor?
Yeah. Thanks, Dr. Dan. If you haven't done so, please send your questions through the panel on the right that pops up after clicking Q&A on the top bar. If you're interested in gaining comprehensive insights and developing expertise in applying MBSE, requirements management, and project management techniques, join us at our Innoslate Innovations Bootcamp, June 3rd through the 5th at our office in Manassas. To learn more and sign up for the opportunity, the link will be included in the email with the recording and slides for this webinar. All right, we've received several questions already. We'll answer as many as we can before our time is up. First question is, can you import from Jira?
So I have not done that myself. I know we've had a Navy customer do some of that work. I believe you can, we have a round trip capability with GitHub. So I think it's feasible, but I just haven't done it. It's not something we use, so.
Next question, how is the Kanban board created?
So the Kanban board is created in Innoslate by the different relationships between things. So if I go to that Kanban board, as an example, let's get to it. Here we go. Boom. So you can see in here the information, this check 6, and then I look at the relationships associated with it. So this ties to decomposing the demo, which is the main thing, and then scheduled to do. So it's tied to that. So this check 6 element, which is a task, is associated that way. Now, also with this, you have the ability to show an assignee. So here's an example one that doesn't have an assignee. So let's add one to it. And I'll add Dominic to it. So now it's assigned. So this is how this works pretty simply to create the information you're looking for, and through those relationships. So you can, of course, again, this is not something I use a lot myself, so you will want to read more of the help package for this. By the way, if you did not know, we have a help bot now, so you can go select that and say, how do I use the Kanban? So this takes you through the process of that. And then, and it's a bit of a process. And then, of course, there is links to help you go to it in the Help Center. So you just select one of those and it takes you right to that article on the Kanban board as well. Okay.
Next question. How
Uh-huh.
big a system can Innoslate handle?
So we designed it to scale. That's another reason we went to the cloud. In fact, one of our big drivers for Innoslate was the NASA chief engineer was going around talking about how they had systems with millions of parts, and they needed the capability to be able to scale to those kind of levels. So we've tested to 10 million objects. So I think that's pretty good size. It will depend on your back-end hardware as well. You will have to make sure you have the right virtualized servers set. So I believe it could grow well beyond that, but that's what we've tested it to.
Next question. Can a large team use Innoslate to work together?
Yes, we've also tested it to 500 simultaneous users. So again, that's pretty enterprise grade. I don't know if 500 would be on the same project at the same time. More than likely, you would probably partition the project into different Innoslate projects, separate ones, your program into those, and then they would then interact as appropriate because we can share data between projects in Innoslate. So that gives you the ability to share information, but it also can hide information. So you could have multiple contractors working. You could take their information, bring it together into a master. If those individual contractors didn't have access to that information, you could still give them access to that master project, but they'd only see their information that was appropriate and the common information you created, not the other competitors' information. So we really care a lot about intellectual property and making sure that you can deal with that problem. I know that's been identified as a big problem by a lot of organizations.
Our last question is, what was the most complex system you've used Innoslate to design?
Well, most recently, it was probably that high energy laser test bed that we did for the Navy. That test bed was consisting of about 6 trailers, I think, for the high energy, so trailers of equipment. And we were down at the software message level in terms of analysis. So we were pretty deep into that. uh, so yeah, that's the one I think I was mentioning. I think I was down 12 levels of decomposition. It was so big we couldn't show the Gantt chart, or the 3D diagram on the discrete event simulator, because it would be it's just too much data to put on there. So those are kinds of things that make it a little harder. But it was very complex. Let me put it that way. I've certainly worked on bigger scope things than that, where we've worked on architectures at the top level and things like that. Some of that kind of thing that we've done, but that's probably the most recent one I did. Any other questions?
That's it. Thanks, Steve. We would like to thank you again for joining us today. As a reminder, we'll be following up with you very soon to send you a link to the recording and the presentation slide deck. We hope you can join us for next month's webinar, Predict, Analyze, Optimize, System Simulation with Innoslate's MBSE Tools with Dr. Dam on Tuesday, June 24th. Your link to sign up will be in the email that is coming soon to your mailbox with the slides and recording. We also encourage you to visit our website and our blog, as well as connect with us on social media. That concludes today's presentation. Have a wonderful day, and we hope to see you at our next webinar.
Thanks, everybody.